You want 1 or 2? 2? Okay, let's do 2. Why is subtracted? You solve from here, and this is going to be this equal to this minus that goes the other side. Right? Okay, let's do this problem here. This is kind of a problem usually in the exam. So we have 2 equilibrium constants from 2 chemical equations, and we want the equilibrium constant for another equation. So you already know from practice exams. Basically what you want to do is to form by adding these 2 after you manipulate them accordingly, right? You add them after you manipulate them accordingly to get this equation. That's what you're trying to do. When you manipulate this accordingly, so you can get by the addition this, accordingly you change the equilibrium constants. And then when you add those equations, the equilibrium constant of this equation will be the product of these new equilibrium constants here after these equations have been manipulated. Right? Okay, so these problems are actually two, because you just have to think. You cannot memorize here. I love these problems. And they can be easy or they can be really challenging, really hard. Okay? So you have to know how to think. So what do you want? You want an equation that has A on the left, B and C on the right. If I add them the way they are, whatever, I have A on the right, so there's no way to happen. So if I want to have 2A on the left, I have to do what for the first one? You can see that I have to reverse the first one, right? So the first one is going to become 2A 4B gives you 3D, and the new equilibrium constant K1 prime is going to be 1 divided by x. When you reverse the equation, you reverse right? The equilibrium constant. You remember that? Okay, now, I got my 2A's, but if I add this now to that, I don't get this, because I want C on the right, I want 9C on the right. I see C here on the right, that's good, but I want 9 C's, and I see 3 C's there, so what I'm going to do? I'm going to multiply this one by 3. So it's going to become 3D. That will give me 9C. Do you agree with that? That way I will have what I want. I will have this, here it is, and I'll have this, here it is. How about happens with this and the other ones? Magically they will come to their place. Right? So K2 prime is going to be equal to what? Y to the cube, right? You want to multiply by 3, you raise the equilibrium constant to the power. So let's add now and see what will happen. 3D, 3D goes away, and voila, 2A gives you 4B plus 9C, and the new equilibrium constant K3 is going to be the product of these two equilibrium constants. So that will be 1 divided by x times y to the cube, which will be y to the cube divided by x, and therefore the answer will be D. Right? So that's more or less, this is the way you seem to do this problem, right? But sometimes they might have 4 equations or 5. They can be quite challenging. But if you know how to think, it should be okay. The intriguing thing, the incredible thing is, in every meeting we have as educators, we say we're working on critical thinking. We want our people, our students, to think critically. Is it happening? It's not happening at all. We are not honest to ourselves. We are hiding behind our finger. Our students are not thinking critically, no. When we bombard them with so much information, they cannot lift up their nose up to take a breath. That's not critical thinking. Critical thinking comes when you don't have any anxiety. When you have anxiety and stress, you cannot think critically. We know that. When things get in panic, people do crazy things. They don't think critically, do they? To think critically, you have to be totally non-stressful. No stress. Isn't true or not? Huh? What's that? It depends. It depends. Should we do the number 11? Okay. Number 11 has a solution of hydrochloric acid. Instead of hydronium ions, let's say H plus, so we'll finish up faster, right? Equal to, you have hydrochloric acid, you have hydrochloric acid, you have iodic acid, you have hydrofluoric acid. You got all the hydrohalogen acids, right? Well, you know that this and that, they're strong, yes? And you know that this is weak, correct? And you know that when you have strong and weak, you completely forget the contribution of hydronium ions to the total concentration of hydronium ions, that they come from water ionization or weak acids. You just consider the ones that come from strong. So, hydrochloric acid is strong, then this will give you how much? 0.85 M, correct? The hydrobromic acid is how much? 0.15. That will give you also the same concentration because it's a strong one, 0.15 M. And then we have 1.0 times 10 to minus 8 hydroiodic acid, and that will give you also the same concentration of hydrogen ions. Okay, and you add them, right? You can say this, so later on you will remember. About 0. So the total here, H plus total, because from water is almost 0, hydrochloric acid is almost 0. These concentrations are pushing the water all the way down to the left. So it's going to be 10 to minus 8, 10 to minus 9, 10 to minus 10, forget it. Right? Same thing with this too. So the total then is going to be equal to what? 0.85 plus 0.15. How about this? Forget it. Why forget it? Well, look at this. 0.8 and 0.1 plus 0.1, 0.000001. Forget it. Right? Hey, there you go. Hey, you guys, you see these guys love you. Don't they? They follow you whenever you have stress. They are stress relievers. So the concentration is 1, and therefore the pH comes to be 0. So there is problem that they have 0 pH, right? pH can be 0. Well, they're working on new songs for you. They have new songs every time they come. Isn't that beautiful? Huh?